In this lesson, we will learn about polynomials. To begin with, let us consider the algebraic expression 3x square plus 4x plus 5. So if you observe closely, in this algebraic expression, there are three different parts, and each part that makes up this algebraic expression is called a term. And the letters in this algebraic expression, which are x, are called variables. And the numbers before the letters 3 and 4 here are called coefficients. And finally, a number appearing by itself without any letter is called a constant. And the power of the variable is called the degree of the term. So in this case, the first term, the degree of the term is 2. So a degree of the term is determined by the power of the variable of the term. So in here, the power of the variable is 2. So the degree of the first term is 2. Whereas in the second case, the power of the variable is 1. So the degree of the term is 1. So a polynomial is defined as an algebraic expression made up of different terms that contain positive integer powers of variables. So if you consider the above expression, it is made up of different terms and each of its variable has a positive integer power. So this is a polynomial. So whereas if you consider 3x plus 6 by x, this can be written as 3x plus 6 multiplied by x power minus 1. So this is not a polynomial because it has a variable with a negative power. So this is how you can identify whether an algebraic expression is a polynomial or not, by just looking at the powers of its variables and making sure those variable powers are positive integers. In the previous lesson, we have talked about degree of a term. So for example, the algebraic expression 3x square plus 4x plus 5, we mentioned that the degree of the term is the power of its variable. So in this case, the power is 2. So the degree of this term is 2. And over here the power is 1. So the degree of this term is 1. But what about if we have expressions like 3x square y square plus 4x cube y square plus 3. So how do you calculate the degree of the term in this case? So a degree of a term with multiple variables is equal to the sum of the powers of its variables. So in this case, the degree of this term is 2 plus 2, which is 4. And over here it is 3 plus 2, which is 5. And a degree of a polynomial is same as the degree of the term which has the highest degree. So in this polynomial 1, the term with the highest degree is 2. And in this case, the term with the highest degree is 5. And the degree of this polynomial is 5. So the degree of a polynomial is same as the degree of the term with the highest degree. So let us continue our discussion on degree of a polynomial. So consider the algebraic expression an x power n plus an minus 1 x raised to the power of n minus 1 plus so on to a1x plus a0. So if I say that this expression is a polynomial of degree n, then a0, a1, a2, a3 so on to an are all constants, and an in particular should not be equal to 0. Only then I can say the degree of this polynomial is n. But if a0, a1, a2 and an are all zeros, then this expression will turn out to be 0. And the degree of 0 is undefined. Now we will define polynomials based on their degrees. So if the degree of the polynomial is undefined, then it is called a zero polynomial. And the example is only 0. If the term is 0, we call that a zero polynomial and its degree is undefined. Whereas if the degree of the polynomial is 0, we call that a constant polynomial. And for examples of a constant are like 5, 2 by 3, minus 10, etc. All these terms have a degree of 0. We can assume 5 as 5x power 0. So the degree of this term is 0. Similarly, if the degree of a polynomial is 1, it is called a linear polynomial. Examples are 5x plus 3, 6x, 7y, so on. The degree of the polynomial is 2, we call that a quadratic polynomial. Examples are x square plus 5x plus 1, 6y square, ax square plus b, etc. So degree of the polynomial is 3, we call it a cubic polynomial. And the examples are 3x cubed minus 7, x plus 6, 7z cube minus 1, etc. So in this way, the name of the polynomial is determined by the degree of a polynomial as shown in this tabular form. Next, we will talk about the names of the polynomials based on the number of non-zero terms in a polynomial. If there is only one non-zero term in a polynomial, it is called a monomial. Examples are minus 2x, minus 3z cube, 5y square. If you observe, these are all polynomials with one single term, and these are called monomials. And note that the degree of these terms can be 1, 2, 3. So we are only looking at the number of terms here, not the degree of the term. So similarly, if there are two non-zero terms in the polynomial, it's called a binomial. And the examples are 3x plus 5, 6x square plus y. So again, if you observe here, there are two terms in the polynomial, and the degree of the polynomial could be basically anything other than a negative number. Similarly, a polynomial with three terms is called a trinomial, and the examples are as seen here: 4x square plus 2x plus 3, x square plus bx plus a. So these are all polynomials with three terms. And any polynomial with more than three non-zero terms is called a multinomial. And an example is a 4-term polynomial, as you see here. Next, we will learn about a special property of linear polynomials with one variable. A linear polynomial with one variable is always a monomial or a binomial. So what do we mean by this? So if you remember, a linear polynomial is a polynomial whose degree is 1. So how would you write a polynomial whose degree is 1? So one of the examples could be 3x. If you look here, the degree of this term is 1, and the polynomial itself, the degree would be 1. So in this case, this is a monomial. Or you can have a constant term like this, 3x minus 5. The degree of the constant is 0, and the degree of the first term is 1. So the degree of the polynomial is 1, which means it is a linear polynomial. But the number of terms in this polynomial are 2. So this is a binomial. So now you can ask the question, Okay, you have shown us that 3x is a monomial and 3x minus 5 is a binomial, and both of them are linear polynomials because their degree of the polynomial is 1. How about I can construct a polynomial with 3 or more terms and still have the degree of the polynomial as 1, right? Then this statement would be wrong because now I'm constructing trinomials or multinomials and still maintaining a degree of 1, and so hence it will be a linear polynomial. So let's see how we can construct that. Consider the polynomial 3x minus 5. So if I have to add a new term to this polynomial and still maintain the degree of this polynomial to be 1, I should either add a term which is in the form of ax, where a is a real number, or add a constant b, which is again a real number. So let's add that ax plus b. So now I have a polynomial with more than two terms. You have to also be careful, like the a cannot be equal to minus 3. In that case, if it is minus 3, the first degree polynomials get cancelled out and it's no longer a linear polynomial. So for any other values other than minus 3, we can always simplify this expression to be 3 plus a times x plus b minus 5, right? So now if you observe this, for any value of b other than 5, this is in the form of a binomial because px plus q. For b equal to 5, this term gets cancelled out and you will remain with 3 plus a x, which is in the form of px, which is a monomial, right? So no matter what terms that you add to this polynomial, you will always end up with either a monomial or a binomial as long as the degree of the polynomial is 1 and it always has one variable. This is a very key point because I can have a linear polynomial like this 3x plus y minus 5. This has three terms and the degree of the polynomial is still 1 because the degree of these two terms is 1. So the term with the highest degree is 1, so the degree of the polynomial is 1. So this is still a linear polynomial, but now it is a trinomial. So this statement holds only for polynomials with one variable and degree 1. So a linear polynomial with one variable is always a monomial or a binomial. Next we will talk about polynomial notation. If the variable of a polynomial is x, you can denote that polynomial by using this notation, where you put the variable in brackets and then you will prefix that brackets with a small case letter. This can be pretty much any letter from A to Z, right? Like it can be Q of x, B of x, D of x, so on. So let's consider this polynomial 3x cubed plus 4x square plus 6x minus 10. So if you observe, this is a polynomial with a variable x. So you can denote this as p of x equal to 3x cubed plus 4x square plus 6x minus 10. If you have another polynomial, let's say ay square plus by minus c. So this is a polynomial with the variable y. So you can denote this as either q of y or pretty much any small case letter and of y. So this is how you denote polynomials using this notation.